In this video, you will learn to find an equation of a hyperbola and ellipse with its center not at the origin, as well as how to identify a conic as a circle, ellipse, or hyperbola. So what's new in this lesson is the fact that the center is being shifted. So all the rules we've learned up to this point still apply, just with the difference where the center is not at the origin. So we're going to take a look at both ellipses and hyperbolas. And for both these, the center is at a point, we'll call it HK. So with ellipses, we have the two different scenarios. One is where the major axis is horizontal, the other is where the major axis is vertical. So beginning with a horizontal major axis, remember what that means is that the larger number, we'll call a squared, is under the x term. All right, so everything is the same, but notice here in the numerator we have a minus h with the x and a minus k with the y. So whatever is in the parentheses up here in the numerator with x and y, that will give us the center. All right, so if it's with the x term up here in the parentheses, it's going to let us know what the x number is for the point, for the center. And whatever is with the y in parentheses, that number will help us find the y value of the point. The only thing is to be aware of that the signs are opposites. So a negative number in the parentheses gives you a positive number for the point. All right, so if this were like x minus 3 squared, it would be a positive 3 for the x value. And if it was y plus 4 squared, it would be a minus 4 for the k value. All right, so it's switching. All right, and still with the foci can be determined by a letter we'll call c, and the relationship between a squared and b squared is still c squared equals a squared minus b squared. And it's still the fact that from that center point, we need to add and subtract c for the x value to figure out where the foci are. So again, nothing's really changing other than the fact that the center is being shifted. We still subtract and add c just like we would before with the center at the origin. And then if the major axis is vertical, so meaning it's going to be skinny up and down, or it's longer up and down, it's going to look like this. So it looks like this because the a squared term is the larger number that is underneath this y term right here. So that's how we know it's going to be vertical. And the shift is still being the same. So if it's h here, whatever is here with the x value, that will give us the x value for the center. And whatever is here with the k value, with the k number, or with the y, sorry, that's going to be the k number for the center. So same thing as with the horizontal major axis. All right, so if this were like x minus 3 squared plus, then you have y minus 4 squared, it would be just changing the sign. So if it's x minus 3 squared, it would be a positive 3 for h. And then if it was y, let's say plus 4 squared, it would be a negative 4 for k. All right, so the signs will change. And again, the foci are determined the same way. We can take a squared minus b squared, and that would give you c squared. And here we need to add that c value to the y component of the center, because the foci will be on that major axis, which goes up and down. So we have to add and subtract c from the y value of the center. All right, and then with hyperbolas over here, same thing. We have the horizontal major axis. So the only difference here is the h and the k. So again, whatever is with the x term, that will help us give the h value or the x value for the center. Whatever here is with the y term in parentheses, that will give us the y value for the center. And again, same logic for the foci. Okay, we can find it using this relationship of c squared equals a squared plus b squared. And here you have to add or subtract c from the center point, from the x component, because the axis is horizontal. And then if the major axis is vertical, all right, still the same idea, same thing, where whatever is with the x term will give us the center, whatever's with the y term in parentheses that will give us the y component of the center. All right, so whatever's with x gives us the x value, whatever's with the y gives us the y value. And again, the foci, we just add and subtract c from that y component of the center. That'll give us the foci. Okay, let's take a look at an example of this. That way we get some practice with this new information. So here we are told to identify the conic, and we are to give it center and foci as well as to graph. All right, so here is our equation. Now what type of conic would this be? Well, this would be an ellipse because it's got an x squared term plus a y squared term equaling 1. All right, this would be the format of an ellipse. If it was a minus sign, it would be a hyperbola. And the center we can find by looking at this number and this number. So the positive 2, change the sign, that gives us a negative 2 for x because it's with the x term. And then this minus 3 would give us a positive 3. You change the sign, and this goes with the y component, the y value, because it's with the y term. So the center would be at negative 2, comma 3. Now to find the foci, we need to use the relationship that c squared is equal to a squared minus b squared. So a squared would be the larger number, that's 25. B squared would be this 21. So you just subtract those, 25 minus 21 to get 4. C squared is 4, so c would be plus or minus 2. All right, now with this ellipse, okay, it is the major axis is horizontal because the x term has a larger number underneath, which means it's wider left and right. So it's going to be horizontal. So at negative 2, 3, we'll try to make it more accurate. The center is here. Okay, we need to create an ellipse with that as the center. It's going to look something like this. Okay, not the best picture, but you get the idea. All right, so with that being said, your major axis is going to cut across like this across through the center. And we know that the foci will be on that major axis, which means we need to add or subtract the c value from the x component of the center, right? Because it's being shifted left and right. So we take that center of negative 2, 3, and we're going to add the c value of 2 to the x component, and we're subtracting the 2 from the x component to get our foci, which gives you 0, comma 3, and this would give you negative 4, comma 3. So we see that typed up right down here. All right, now we were told to also graph. So we have the center, we have the foci. To graph this, okay, we see it here already given to us, but let me explain how you would know what to do. So you would have the center point, right, which you see right here. You can graph the foci, you can put that right there. Now to figure out how high up and down we go and how far left and right we go, we still use these numbers just like we did if the center was at the origin. So if you take the square root of 25, that gives you 5, right? So that gives us how far to go from the center, left and right, in the x direction. So if you go from the center to the left 5, that takes you over here to negative 7, 3. And go to the right 5, it takes you over here to 3, 3. So we have those 2 points, and then do the same thing for the y value. So this 21 here, we take the square root of 21, and if we do that, it's going to be 4 point something, and I think that's 4.6. All right, so we go from the center in the y direction up 4.6 to take you to this point, and then down 4.6 to get to this point. Once you have those 4 points, and we have the center, we just connect those 4 points with a curve to create our ellipse. All right, so most everything is the same. The only main difference is the center is being shifted over. Let's try another example. Here we have this equation, and we are to identify the conic and also give it center and the foci, and then graph. Okay, so this shape would be a hyperbola, first of all, because of the minus sign connecting the two terms. So that's a hyperbola. Now the center is being shifted. Okay, so the center is made up of an x and a y value. If you take this -4, you change the sign to a +4, and that gives you the x value. We know it's x because it's with the x term. This -5, change the sign to be a +5, and that goes here as your y value, and we know it's y because it is with the y term here in the parentheses. So your center is at 4, 5. So we have the center. Next, we want to find the foci. So to find the foci, we need to find the c value. And with an hyperbola, what we do is use the relationship that c squared is equal to a squared plus b squared. All right, so a squared is always the first term, 24 in this case. So it's this number right here. The b squared would be this 25. So we have 24 plus 25, which gives you 49. So c squared is 49. So c is the square root of 49, which would be a positive or -7. So the question is, do we add this to the x component or the y component of the center? Well, to answer that question, we have to figure out which way is a hyperbola opening. All right, so if you were to sketch this quick, we have 1, 2, 3, 4, 2, 3, 4, 5. The center is right here. And because the 25 is bigger than 24, and it's with, sorry, that's for ellipses. Because the 24, or the x term, is coming first, that's how we know it's going to be facing in the x direction. So it's going to be opening left and right. So it's opening something like this right here. So opening like that, and opening like this. And that's because the x term comes first. If y came first, it'd be opening in the other direction, up and down. So what that means is that the major axis is going to be horizontal. So it's opening horizontally. So the foci need to be shifted horizontally as well, meaning we must add the c value here to x for the center. So if you do 4 plus 7, that gives you one foci, or one focus. And then we do 4 minus 7, that gives you the other focus. So what that gives us is 2 points of 11, 5, and then -3, 5. So that's your two foci. So we see that typed up right here. And if you had to graph this by yourself, okay, here we see what the graph would look like. But the question is, how do we come up with that information? Well, we have the center, okay, so we can put that on there. We have the two foci, we can put that point, those 2 points on there. So the question now is, how do we know where to start with the hyperbola? How far from the center do we have to go, left and right? Well, to determine that, it's the same as with the ellipse, where you take the square root of the 24 and the square root of 25, which would be 5. All right, so the square root of 24 is going to be 4.899. So that is how far from the center you need to go left and right. So that takes you to these 2 points you see here, the 8.899, 5, and -0.899, 5. So we have those two starting points for the hyperbola. And then to figure out the asymptotes, okay, once we have those 2 points from the center, because this number here is a 5, that's with the y term, that tells you to go up 5 and down 5 from the center. And that takes you to the top and the bottom of this little box we've created. So we have this box created with the dimensions being from the center up 5, down 5, and then to the left is the square root of 24, and to the right, that same distance. Once you have the box, the asymptotes can be created by connecting the vertices. So we create two diagonals going through the box, and that gives you the asymptotes. So now once we have all that information, we can graph the hyperbola starting at these 2 points, and then going away from the center, and it's going to approach the asymptotes but never actually reach it. So that would be how you would graph this picture. So we've done one with an ellipse, we've done one with a hyperbola, and all of those that we've dealt with have been in the correct format. Okay, here we have an example where it's not in the correct format, and you have to rearrange such that we can graph, and we can determine what type of shape we have. So for this one, all right, what we want to do is we want to get it to be something squared, then plus or minus something else squared, equaling 1. All right, and we know it's going to be something like that because we see both an x squared and a y squared. If it was just one variable being squared, it would be a parabola of some sort. All right, but here we have two variables being squared, so we're going to have something like this. So what you want to do is you want to basically set this equal to a constant. So let's bring this negative 20 to the right side by adding 20. Okay, we'll turn it into a 1 in a little bit. And then we want to group together the x's and the y's. So we see that typed up right here. So you put together the x squared and the minus 4x right here, and then the negative 12y squared and the negative 24y, you group together right here, and then we set it equal to 20 by bringing this to the right side. Now from here, you want to create yourself a little bit of space, because what we're going to do is we're going to complete the square for both the x and the y terms. So for the x's, we have x squared minus 4x, create a space, and then we have the minus 12y squared minus 24y equals 20. Here we want to pull out a negative 12. So you're left with the y squared. This becomes a plus 2y, leave a blank, and then equal to 20. All right, so this is what we have to work with. So from here, the question is, what do we have to add into the parentheses to force this into a perfect square? Well, to do that, you take half of this middle term and then square it. So half of negative 4 is negative 2. Square negative 2 to get a positive 4. Same thing here. Take half of 2 to get 1. 1 squared would be 1. But remember, what you add to one side, you must also do to the other. So here we added a 4, so we have to add 4 over here. And then this plus 1, just be very careful because this plus 1, you have the negative 12 outside of the parentheses, meaning the negative 12 is actually being multiplied with the 1. So by putting a 1 here, in reality, what we've done is we subtracted 12, negative 12 times 1. So on the other side, we must subtract 12 as well. So now we have x squared, this can factor to be x minus 2 squared, and then we have minus 12. This can factor to be y plus 1 squared, and then we have 24 minus 12, which would be 12. So we see all of that typed up, and that leads us to this point right here. Now to finish off, we want to set this equal to 1. So to do that, we have to divide everything by 12, because 12 divided by 12 would give you a 1 over there. So divide this by 12, and then divide this by 12. So when you divide this middle term, 12 divided by 12 cancels. That gives you a 1. And what we have is x minus 2 squared over 12 minus y plus 1 squared over 1 equals 1. And now this is in the correct format. So from here, okay, we can determine that this is a hyperbola because of this minus sign right there. Everything else is in the correct form for a hyperbola. And then the center would be found by looking at this negative 2 and the positive 1. You switch the signs to get positive 2, negative 1. And then for this one, we're also asked to find the intercepts. So to find the intercepts, what we do is we have to plug a 0 in for x and for y. So for the x-intercepts, you plug a 0 in for y, and then solve for x. All right, so we have x minus 2 squared over 12, and then minus, this would be 0, equals 1. All right, so that cancels out. So we have x minus 2 squared, and then multiply both sides by 12. X minus 2 squared equals 12. And then we can take the square root of both sides. So you have x minus 2 equals plus or minus the square root of 12. Add 2 to both sides, so x would equal 2 plus or minus the square root of 12. All right, so that would be your x-intercepts. And we see that typed up right here. And then for the y-intercepts, you plug a 0 in for x. So we have a 0 in here. And then we solve this for y. So that would give you negative 2 squared. So that gives you positive 4 over 12 minus y plus 1 squared over 1 equals 1. So we can get rid of the fractions by multiplying everything by 12. That gives you 4 here. Gives you a 12 times y plus 1 squared here equals 12 over on that side. And I just rewrote it up here to make myself a little more room. Then we solve this for y. We can subtract 4. So we have negative 12 times y plus 1 squared equals 8. And then we can divide both sides by negative 12. So we have y plus 1 squared equals, that'd be a negative, and we can reduce to get 2 over 3. Now notice from this point we have to take the square root of both sides, but when you take a square root of a negative 2/3, that's imaginary. So because of that right there, we can determine that there is no y-intercepts because that is imaginary. So we have found the center, we found the intercepts. Now to finish off, we need to find the foci. To find the foci, we can use the relationship of a hyperbola that c squared would equal a squared plus b squared. So we have 12 and 1 as your a squared and b squared. That would add to give you 13. So c would be a positive or negative square root of 13, which would be about 3.6. So for this hyperbola, because the x squared term comes first, we know it's going to be opening left and right like this. That means the foci will be moved from the center, a certain amount to the left, and then a certain amount to the right. Okay, so the center is at the point 2, negative 1. So we need to add and subtract 3.6 from the x value. So if you add 3.6, that gives you 5.6 for x. And if you subtract 3.6, that gives you a negative 1.6 for x. All right, so we have to add and subtract that from the x value to move it left and right to find the foci. So we have done what this question is asked for. We found the center, we found the intercepts, and we've also found the foci. Now, working backwards, if you had to find the equation of one of these shapes, so you're given maybe the foci and the center, how would you find the equation? So in this example, we're trying to find the equation of an ellipse. And what we're told is that we have foci at negative 2, 5 and 8, 5, and the length of the major axis is 14. So to begin, we want to find the center point. To find the center point, it's going to be right in between or in the middle of these 2 points. So what is the midpoint or the middle of these 2 points? Well, you can average the x's and average the y's to find that. The y's are the same, so the average of 5 and 5 is still 5. If you average the x's, you add negative 2 and 8 to get 6, then divide by 2 to find the average. That gives you 3. So the center is at the point 3, 5. And then we also know that our c value is the distance from the center to one of the focus. So from 3, 5 to 8, 5, for example, that distance from those 2 points is 5 away. All right, we can find that based off the x values. So we know c is 5. The major axis has a length of 14. And remember the relationship with the major axis and the letter a is that the major axis is 2 times the letter a. So 2 times a is 14, divided by 2, a would equal 7. So we have c, we have a, now we can find b by using c squared equals a squared minus b squared. So we plug a 5 and a 7 in for c and for a. We now have 25 equals 49 minus b squared. So we subtract 49 from both sides. When you do that, you have negative b squared equals, that would be a negative 24. So b squared would be a positive 24. And if we wanted to find b, just take the square root of both sides, but we really don't need b, we want b squared. And with an ellipse looking like this, okay, it's going to be in this format right here. Okay, we know it's going to have the a squared term underneath the x term, underneath this x value, because the foci are on the major axis, and the major axis is horizontal, right? If you graph those points, okay, it's going to be one here and then one over here. All right, so it's going to be horizontal, and so the larger number goes under the x term. So a squared, if you square a, that gives you 49, and then if you square b, we have 24. So we have 49 there, 24 underneath this term. In the center, we can find, we can use that to find these numbers by taking the opposite of 3 and 5 to get -3 and -5 for x and y here in parentheses. So this would be our equation of an ellipse. All right, and then we can do this same idea with a hyperbola. Here, a hyperbola have the foci at -2, -3, and -2, 7, and the difference of the focal radii is equal to 8. So again, the center is going to be right in the middle of the foci, which means that you can average those 2 points. You can average the x and the y values. The x value stays the same. That's not changing, so the center would still be at -2. But the y values, you have to average -3 and 7. So you add to get 4 and divide by 2 to get 2. So the center is at -2, 2. And the distance from that center to, let's say, -2, 7, the distance is 5, right? From 2 to 7, that's 5 away. So your c value is equal to 5. So we have c. We can find a because we know that 2a is equal to this 8, the difference of the focal radii. So if 2a is equal to 8, a would equal 4. So we can use that to find b with this relationship here of c squared equals a squared plus b squared. So we square c to get 25, we square a to get 16, so 25 equals 16 plus b squared. Subtract 16 from both sides, b squared equals 9, and we don't need b because what we were concerned with is just the b squared. And when you write your equation, it's going to look like this, in this format. All right, where it's going to be the y term coming first because the major axis is going to be vertical, right? Because -2, -3 would be somewhere down here. -2, 7 would be right above that, up here. So because of that, okay, we know it's going to be opening like this, up and then down. So because of that, because it's vertical, we know that the y squared term is coming first. And then you just plug in the numbers. A squared would be 16, b squared is 9, and then we take the opposite of -2 for the x value to get a +2. So that goes here because it goes with the x term. So this x value goes with the x term, change the sign. And this +2 changes into a -2, change the sign, and that goes here with the y in parentheses. So this would be your equation of the hyperbola. So in this lesson, we've discussed hyperbolas and ellipses where the center is being shifted. And we've also learned how to graph with that, and we've learned how to find the equation with that information as well. And that concludes our lesson for today. We will see you next time.